Okay, so uh, okay, about the quiz. Uh, do you think it's difficult, the quiz? I check. Okay. Uh, check. Okay. Probably I don't need this. Okay, please scan the QR code. And do you think the quiz is difficult yesterday? I've checked several students, I think 9 or 10. Um, I think from 10, 2 or 3, they got around 80 something, 83, 85. Uh, the other one, they got around 50, 40. Um, and there are some who got um, below around 20 and below 20. So that's what I'm concerned. Okay. So I'm not really sure, okay, because I know that some of you are doing your class through online meeting, right? Before you have the quarantine and you are coming late to Taiwan, right? So I don't really know what is the problem. Is it because of the maybe before you came to Taiwan, maybe the connection is really bad, and then you cannot really see the lectures, and perhaps when I record into YouTube, you also have a problem to see it in YouTube. I don't really know, but what I do really know is uh, the concept you have before. Okay, this is really important. I know you have different backgrounds, okay, with different um, how to say it, different understanding in math, either because of your previous curriculum doesn't really meet the standards in Taiwan, or it's just because of you. I don't really know, and I don't really care about that actually. What I do really care is when you are coming to Taiwan, you enter the class. I want you to be able to achieve the standards the Taiwan has. I'm still appreciate your coming to the class. Even some of you are really uh, not really at that standards. It doesn't mean that you are bad. No, I don't really mean in that way. Okay, what I do really mean is when you have that standard, okay, you need to put a lot of efforts. Okay? I talk uh, previously in calculus class. Maybe some of you are in the class. Um, to be able to survive, okay, in all conditions, okay, whether you are learning in university or after your after you graduate, you want to work in some company, because of course you are in a new environment. You need to adapt easily, right? You need to get along with others and get to know of the system, right? So I told you at my previous class, every matters. or everything in this physical universe, in the universe, okay? Everything that has relations with any physical phenomenon, okay? I want to relate to concept of thermodynamics, but I'm not really sure that you understand that. But let's say you have iron, okay? Iron, okay? Like for structure of the building, you have iron. Okay? In the nature, okay, the iron is not pure. Am I right? I think you are maybe familiar with how to purify the iron. Okay. So you know the ore, right? You heard the ore, like from the mining side? So you are mining some ore, say, okay, I got my iron ore, but can you use it directly to a building? Okay, this is iron. No, right? It's different. It has different properties, right? Because I'm from material science, I have a background in materials. So it has different properties. So you need to put some efforts, get some high energy for that iron ore to be pure, right? Basically, you give some hot temperature, high temperature to get the pure of the iron. Okay. Okay, you get the iron. Now you get the iron you are using in the building. But is that any? Is it possible that the iron can get rusty? Possible, right? So sometimes you need to paint some painting, some coatings. It can prevent corrosion, prevent rusty, right? Because if your iron rusty, then it tends to be broken, right? It easily to be broken, right? Okay. So in nature, okay, in nature, everything has a preference. Every small matter has a preference. In thermodynamics, we call the energy of activation. So we need small energy to activate uh, the activity. Okay. So in short, everything has a preference to rest. Okay? Like us, we wake in the morning, right? And we have a choice. We get up early, brush our teeth, maybe take shower, or maybe packing our bag, right? We have a choice. One, option one. Or we have choice two. Okay, give me more 5 more minutes, I'm asleep. We tend to have more sleep, right? We choose to sleep more than we wake early. Am I right? It's nature. So everything in nature has a tendency to rest, tendency to, okay, just sit and in make ourselves in comfortable positions. Like okay, it's just comfortable. I want to sleep more, right? And that's okay. That's nature. That's fine. That's nature. But what I want to say to you is because it's nature, so it's actually natural for us to be lazy. That's nature. You need to be relaxed, right? You need to be refreshed. Your mind needs to be in a way that okay, I don't like this pressure. I want to okay have some fun. I need to rest. I need to sleep. I need to maybe playing a video game, maybe with my smartphone, blah blah blah, right? And that's pretty much natural. That's life is. Okay? So what I want to tell you is it's okay to be lazy, and that's good. Be lazy. Crazy, right? Be lazy. When your teacher before study hard, practice, blah blah blah. No, what I tell you is be lazy, but smart. That's different. So because you have tendency to be lazy, and that is how innovations work. Do you realize? Okay, with your smartphone. Okay, before I don't really know how to deliver my package, deliver my maybe foods, right? Okay, delivery, Uber Eats, Food Panda in Taiwan, right? Okay, foods come. And we don't really need to go somewhere and take the foods, right? We just wait and then the foods come by itself. That's innovation. Help us to get lazy, right? Am I right? That's part of innovation. So it's nature, and every innovation this will help us to be more lazy. But there's a catch, okay? There's a catch. Because of that tendency, now you have to play smart. Now you have to play smart. How to play smart? You need to put small or minimum effort to gain the maximum output. Okay, yeah, list it, and maybe we can send the QR code. Okay, so what I want to tell you is I don't want to force you to, okay, study this, study that, blah, 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 blah. I know I have my standards that you need to, okay, you need to achieve this. You need to at least have a good mathematical concept for your calculus, for your next engineering related course. Okay, because math is it's basic for all science engineering courses. If you don't have some standards in the concept of math, then I don't really know what happened. Okay? I cannot help you. I couldn't help you. Okay? I can guide you, but I cannot help you if you're still not achieving that standard. Okay? So, okay, again, be lazy, okay? But smart. You need to play smart in your life in all matters that you are pursuing. Even after you graduate, play smart. Okay, play smart, and do not make your life difficult and hard. Okay? For example, you are thinking that you are maybe you are really below the standard, and you are putting your efforts really hard, and then you are ignoring your physical conditions. That's also wrong. That's also wrong. You will get tired, and of course, when you are tired, you will not be focused, right? So balance your life, play smart. It's okay to be lazy. When I was still an undergraduate, I never study after the class. Never. I always focus in the class, try to understand the concept. If I don't, after the class, I'm asking the professor, I'm asking anyone that know the problems, what is this about? After I understand, okay, got it. But I see some students, they approach engineering, science, without really understand the concept. Okay, they just memorize. Oh, the question, how the solutions. Okay, you memorize the solution. Okay, you pass the test, but you don't really understand the whole thing. You don't understand. You are just copy paste your solutions, and okay, this. It won't work. Maybe it will work in exam, but in a concept, no. So I want to push you. No, that's not a good word. I want to suggest you. Okay, everyone here, I believe, has a preference for study. Maybe you have a good visual. Okay, you study through pictures. Maybe that's easier. Maybe some, okay, I need to put some words in it. Okay, that's maybe good for you. I need you to find that. I need you to find your own way. And you will be a lifelong learner. Okay, you will learn anything easily. Okay, because nowadays, even though you are in engineering school, we are not really sure what the future will be, what you need to in the future. We are not really sure, right? So it's good to learn uh, anything that you find interesting and maybe it will be useful in the future. That's good also. Maybe you want to learn some writing skills or some marketing. That's also good for you if you want to practice the skills. Okay, but in basic level, okay, at least you need to have good understanding, especially if you're um, in engineering school. So math is pretty much really basic. Okay, okay, so I want to start the course with some review from yesterday quiz. Okay. Some of you, I appreciate some of you really good. Okay, some make a small mistake, but still giving point. But some uh, it's not really achieving the standards that I believe this class should have. Okay. So my standards, at least 50 is good enough. 50 is good enough. Okay. 50 is good enough. 40 something, it's good enough. But below that, I believe it has a problem with your concept, with your basic understanding of math in general. Right, okay. So let's review. Okay, quiz one. So basic quiz one is covering functions, a polynomial, and log and exponent. Okay. So number one and number two is, of course, it's about the functions, okay? The basic of functions. So number one, what will happen if the functions, so you have functions f of x, okay? I will write some important words from the questions, okay? So these functions stretch vertically by a factor 5. So before dealing with the other words here, try to read these questions or these information, okay? To stretch vertically by a factor 5. So in this case, you need to have understanding in the terms. Okay, okay, what stretch means? Okay, can I borrow the rubber band? Just a rubber band. Okay. Okay, this is functions. Okay, this is just a rubber band. Okay, stretch means if this is the functions, okay, you stretch just like that, vertically, not moving, different. Okay, because I saw some answers. You're just moving 5 times, but it's wrong. So stretch 5 times. So from here, the idea is you have a function. Oh, by the way, you need also to know at least what the square root of x looks like, because some of you still confused how to draw just the square root of x. And you draw like this. Okay, let me give you a really short what you can do from this function. Okay, let me. Okay, this x, a square root of x, we can write this as, okay, that okay? Here? Okay. Okay. I believe if it is x squared, if this is x squared, you know that the graph will be like this, right? It has a curve. Okay. So every x with some power, it will tend to have a curve. But how is the curve? It will depend on, maybe in the calculus you have learned, it depends on the slope, how fast the slope is changing, right? So when you have half, you can also think if if y is x half, okay, let me make solution for x, okay. So I will square y and square the x with half. Okay, I squared both sides. So y squared is x. Okay. So basically, your x squared just moving here. Makes sense, right? So that's how you get the graph easily. You don't need to put some point, okay, 2, 4, 9. I believe when you get the line, you put some point 1, okay, 1, 1, okay, 1 is here. Okay, what is next? Or maybe 4, or 4 and 2. 4 and 2, or maybe here. And you connect the dots. It's wrong, right? But when you change this, it's easy, right? So you get maybe like this. Maybe, okay? Okay. But, okay, but, okay, because now we are focused here, and there is some impossible in this graph, right? When you have x is negative, can it have real solutions? No, so yeah, only that. Easy, right? So sometimes when you're dealing with this is the inverse, okay? This is the inverse. So when you're dealing with the inverse, sometimes the inverse can be switched easily, or some inverse has some limitations, like this one. You cannot have the all graphs like this, okay? Because you have domain, okay? That's the second question, domain. Right? So every time you are dealing with functions, think first is domain, how the functions will roughly looks like. If this is just a polynomial, this is polynomial, but it's half. Or you can think, okay, this is the inverse of just the x squared. Okay. Also, I can also write this as this is x squared. Okay. This is as inverse is x squared. Okay. Okay, but I believe you should be able to tell that. Okay. So this is the square root of x. Let me draw this is the square root of x. And the idea for stretching is like I said before, you stretch. Imagine it's like rubber, stretch. So maybe around here. So 5 factor of 5 means it's like you need to times this curve with 5. So you will have maybe like this. Yeah. So 5 square root of x. Okay. And then the other words, then reflected. Okay. Then reflect to x axis. So this is y, this is x. Okay. So you get this red color here, 5 square root of x. Reflect to x. What do you do? Like a mirror, like a mirror. So if you see reflect to x, meaning x is act like a mirror. Okay. So this is our curve. So our mirror is going down here, right? So let me move the words to here. So it will be like that. So it will be -5 square root. And again, if you are dealing with these typical questions, it's asking just graphing, right? Just a graph. But to be able to tell what is going on in the graph, you need to have a good sense when you are doing the graphing. Okay. At least you need to tell that these original functions have stretched several times. You don't really need to have really scaling 1, 2, 3. No need. You just need to tell me you are stretching here and you're reflecting. Okay. Or maybe your directly answers like this. That's okay. That's good. I I can still see, okay, you already stretch and mirror to this x-axis. That's good. But if you just make like there's like no distinct difference between the original function and maybe your function is just like that. I cannot tell what is the difference, right? Just make it longer. That's good. Good enough. Okay. Okay, so this is the answer for number 1. Okay. Okay, number 2. Uh, functions is equal okay. Find domain, right? So again, it's really basic uh, basic nature in math and function. Okay. So every function has a domain. Means the domain means any x that is possible. Okay. When you put here, the function will be still possible and still in the real numbers. That's the domain means. Okay. And there's also range. Range actually, so domain is for x, range is for f of x, the y. So every domain has specific range sometimes. Okay? But most of the functions, simple functions like just polynomial, the easy functions, it's just, okay, all real numbers can be x, all real numbers can be f of x. That's simple functions. But specific functions, especially these rational functions, yeah, you need to have uh, awareness in this below here. Okay. Okay. So I'm just specifically always saying that if you have this type of functions, okay, uh, and log, the domain problem always most of them will have problem in this 1, 2, 3 types of functions. The first is the rational function where your variables in denominator. Okay. Second one, if you have squared, and it depends. It can be even, it can be 3, it can be 4, it can be 5. It will be different. Okay. If this is 3, can I have negative? I can, right? Okay. -1, -1, -1. It can be negative, right? Okay. So if it is odd, it can be negative. But let's say it's just even. Okay. 2, 4, like this 4. You cannot have negative inside, right? The same as log. You cannot have log negative. Also 0, you cannot have 0, right? So this is, you need to put greater 0. This is still can be 0. So I put equal sign here. And here, the first one, the left, it's not equal 0. Okay? Okay, just these three types of functions that you need to be careful when you need to find domain. Okay. Then we see our functions here. It's fractional functions like this. So the whole part here, we need to not equaling 0. But also we have this, right? So we need to have from both not equal and greater. So we need to have x. Okay, do you agree with me? We need to have this. Okay, and then we solve. Okay, we solve x minus x to the 4. Let's say you solve through factorizations. Okay, to avoid mistakes in the less or greater or any inequality, to avoid any mistakes happen below here. Okay, let's just make this is equal first. Let's just make equal first. Okay, to avoid your mistakes. Okay, so this is usually what I do. Okay, why I do when I having this problem. Just make it equal first. Okay, this is just a calculation. Okay, not the real answer. Okay, if you are confusing about the equal or inequality, just make it equal. Okay? So x is 0 and x is 1, and x is, it can be 1. Can it be negative? No, right? And then, oh, and then you get 0 and 1. Draw line number. I will always suggest you to draw line number and put 0 here and put 1 here. Okay. Let's just say 0 and 1. Let's just say this is just our point here. Okay. But remember, when you plug in 0 to this equal, 0, 0, 0, 0, 0, 0, 1 is 0. So 0 will be 0, and 1 is also be 0. But we don't have equal signs actually, right? So we put whole, right? It become a whole here. So you don't include 0 and 1. Next thing, try some numbers. Try number here, try number here. Try just some easy number like negative 1. What will happen negative 1 here? Negative 1, and negative 1 will be positive, right? Negative 1 is negative. We need positive, okay? So this is negative, okay? Maybe try after 1, maybe 2. 2 minus 2, some power 4. Of course, it will be 2 minus something 16. 2 minus 16 is negative, right? And probably in the middle. Okay, try half. Half. It's true, right? You get half minus 1 over 16 if you put half here. Of course, half is greater than 1 over 16. Agree? Or do you still have difficulty to see this? Sometimes when we are in exam, we feel nervous, right? This is what you can do. Okay? If you cannot tell which one is greater, half or 1/16, try multiplying, crossing this. This will be 16, this will be 2. So this is greater than this, right? So half is greater than 1/16. Okay, okay. So this become positive. and our purpose is to find positive, right? Okay, so this is the answer. And you can write the domain will be from 0 to 1. And again, okay, you need to be careful from here, okay? If you put like this curved bracket like this, it means it's not include 0 and 1 like this whole. Okay? If you put like a rectangle and here a rectangle, meaning you are including that number into the function. Okay? So this is the answer. Or you can write the answers like this is also fine. This is also okay. Both correct. Okay. So this is number 1, number 2. Okay. Number 3 and 4. This is related to polynomial and quadratic. Okay. Okay. So number 3, I will write the functions x cubed plus 8x minus 4. Okay, it say that use the card rule, but I think most of you, maybe some of you forget what is the card rule. So use the card rule to find the possible of the roots, okay? Possible of 0. Okay. So to use the card rule, first for positive 0, we just see the original functions f of x. And check whether when the functions change in sign. Okay, it's positive, right? Positive, negative. This will be 1 changes, right? And negative and positive. 2, positive, negative. 3. So we have 3 change. Okay. Meaning in the card rule, that means we have possibility of 3 positive roots or zeros, or we need to minus the even number, the whole number. So minus 2 or 1 positive roots or zeros. And then the second one, we need to check the negative zeros. So we change x into negative x and plug in back to the equation. So negative x cubed, negative, negative, positive, negative, negative, right? So negative x cubed, okay. Negative x to x squared positive, still the same, right? So we need to just care for the odd number, okay? So it will be the same, it will be changed, it will be the same. Okay, all negative. So this means we have 0 roots for negative, okay? So what the card rules purpose is, it's to find possibility. If you have like this polynomial, it has degree of 3, right? The root should have 3 numbers at least. So the first case is, okay, maybe it's all 3 positive, okay, or 1 positive. But the negative zeros, it's 0. So when it has 1, maybe it has 2 imaginary. That's the possibility. Okay. Okay, let's just check. But because we don't have negative 0, we can just check the positive one. At least when you try and error finding which x is, you can just checking the positive one and ignoring the negative one, right? Okay, let's do that. And we can also see from here, okay? Remember, when you need to find roots, look at the first term and look at the last term, okay? It should be this last term divided by this first term, the factor, okay? So I will write the roots will be factor of 4 divided by factor of 1. But because it's only 1, we can also say we can just skip this 1 and just focus on factor of 4 because it will be the same thing. So factor of 4 means you have plus minus 4, plus minus 2, and plus minus 1, right? Any number that you can make up to 4. 2, 2, 4, right? 1, 4 is only these three numbers. There is no other way to get 4 from the integer, right? So you get this three number. So let's try this three number, but take only positive based on our Descartes rule. So try positive 1, positive 2, positive 4. I just write. You can do plug in if you want, but I will going for syntactic divisions. Okay, divide by first is 1. 1, 1 is negative 4, negative 4 is 4, it's 4 is 0. Okay, so when it's becomes 0, 1 is our roots. Okay. Um, do you familiar with this? With this familiar? Okay. I already also talked in the class. Okay. I hope you also familiar with this syntactic divisions. Okay. So this is also means. Okay. If this is 0, means when we put 1 into our original functions here, it will be 0. So if there is remainder, this is also we call remainder. If there is like 1 or 2 left, so when we, if okay, for example, if this when we put 1, it's 2 here. Okay, if there's 2, mean if we put 1, f1 is equal 2. That's also the way we think about zeros and remainder. Okay, so let's write the new functions after we get uh, the factor. It will be x squared minus 4x plus 4. So I can factorize the second one, right? I can factorize this. It will be x minus 2 squared. And basically, we conclude that this is based on the Descartes rule. Okay, it's actually having 3 positive zeros, right? X is 1, 2, and 2. It has the same roots, but it is multiply, right? It has two numbers that the same. So x is 1 and x is 2. Okay. And then we need to solve the inequality. So the inequality is you need to have whole functions is greater than 0. So let's write the factor. And again, if you are nervous about this inequality, just make it equal first, okay? And make line number. Okay? Just put 1 here and 2 here. Okay, here's the deal. Okay, it's 1 and 2. 1 and 2, when you put, it will be 0, right? But this is greater than 0. So we're going to put whole in this 1 and 2. So 1 and 2 having whole, meaning they are not included. Okay, and then we check all the point. Maybe you can check the easy one. It's just 0 below, nearby the 1. 0, it's negative. Everything that's squared is positive. Positive, negative, it's negative, right? So it's negative on the left. And maybe in the between, maybe you try some number, maybe 1.5. Okay, 1.5 here is positive. 1.5 here, but it's positive, right? It's always positive here squared, so it's positive. And how about 3? Is of course positive. Positive is always positive. So we have this. Okay, but remember, okay, it has a whole. So when you are answering x is greater than 1, it's not complete. You need to equal x is not equal to. So the answer will be, you can write this, and x is not equal to. And also you can write okay, this whole is important because when you say x greater than 1, 2 is greater than 1, but 2 is not included, right? And so this is the answer. You can write like the first one or the second one is also fine. Okay, any questions? Any questions from number 3? Okay. Okay, number 4. Number 4, still polynomial, x to the 4. Okay, you have a polynomial, okay, px, let's say px if, okay, px divided by x minus 1, the r is 4. If px divided by x plus 1, the r is 3. Okay, again, still polynomial, you have remainder. Okay, you will have roots. Okay, you will have roots when you divide, and it has 0 in the remainder. It is roots. Okay, so this we can say that for remainder is equal 4, we can say that when you plug in positive 1, so x minus 1 is the factor, so the roots or the x is 1. So when you plug in x1, it will be 4. Okay. So just plug in 1. 1 minus a plus b minus c plus a is 4. You can simplify this, become minus 5. Okay. This is for the first case. The second case, if we plug in negative 1, we get 3, right? So we plug in negative 1, so it's still 1, negative 1, negative, so plus a, negative 1, positive, still positive. This is positive. This is plus 8, is 3. I can rewrite this. is -6. Okay, so you get two expressions. Okay, and how to solve it? You need to just find b, right? I forgot to write find b. Okay, you have the first line here is -a. The second line is a. This is plus b plus b, same. It says -c plus c. Also different signs. Okay? If I plus these two, I will eliminate a, c, and c. I get b. Am I right? Okay. So plus these two equations. So 2b is -11 and b is -11/2. Or you can say it's -5.5. So this is the answer of b. Okay. Okay, any questions first? I think a lot of you get this, right? Correct. No. I saw some of you writing exactly this 11/2. Okay. Okay, so you can think the remainder like this case. Okay. So the remainder will be, so zeros or roots, when you plug in the number, it's 0, right? Remainder, you will have some numbers left. That's the remainder. Okay, so when you plug in, you have some remainder. I think some of you try to use synthetic divisions. Uh, so you are writing the 1 -a plus b -c, and you need to divide by 1 and divide by -1, and make the last number 4 and 3. Actually, this is you can do it actually. Wait. Okay, let's just see from this page. Okay, so we have still here. Okay, so this is the answer for B. And then for number 5, it's log. Okay, so you have these two log equations. Okay, so first, the idea, okay, is log base of 2x to log base of 4y. Okay, so like I said before, in typical log equations, the first thing you can think is you can make the same base in every sections here. So base of 2 and base of 4 we can make 2 squared, right? So make it 2 squared, and then 4 we can make it log to 16. And this 2 squared is actually we can move to the front, it become half, and it can be just canceling these 2. So log 2y, log 2x, so log base 2 of x, log base 2 of y, and it's become log base 2 of 16. And we got the relations 16 over x, and we have x plus y is 10. So we put 16 over x to here, and we solve these equations. We get the quadratic formula. So x plus 16 over x. So multiply all by x. So x minus 2, x minus 8. So you have x2, x8. So you have 2 possible answers. But you can check whether it's correct or no. Put back to original equations and put y for 8 here. And the second one, put 8 here, the original equation, and put 2 in y. If both correct, then this is the possible answer. So when you have x2, y8, when you have x8, y is 2. Okay. And then, okay, this part. I think most of you didn't make it number 6. So it's 5 times something 5 log x. Okay. So this is not really a log, but it's exponent with log as a power, right? And this is 5, 2 minus log, and it's equal some constant. Okay, x should be greater than 0. Okay, so first is this 2 minus log x. Okay, I need to make separations here. In exponent, you can have okay. So if you have 2, 3, this is 5, right? So if you have 3, negative 2, it's just 8, right? So it's the same thing that happened with log. Okay, so you can make log just like a number, okay? Like a constant. Okay, so 2 minus something, so meaning you can 5 with the power of 2 and 5 with minus log x. And minus log x is actually reciprocal, so you can move to downside here. And to simplify my answer, let's just make 5 log x is a, because we have also 5 log x here. So let's solve 5 log x as a. So a plus 5 over a is 6. We multiply all by a, multiply by a, multiply by a. So you have a squared plus 5, and then it becomes 6a. And that is quadratic, right? So solve with quadratic equations. So a squared minus 6a plus 5 is equal to 0. Solve this. So a minus 1, a minus 5. So you get a is 1, a is 5, but we are not done yet. bring back the original equations, which is the 5 log x, 5 with the power of log x. So put 5 log x here. 5 log x is 1. To solve this, remember to solve the exponent. Okay, this is 5 with power, some power here. If we don't have anything here, if you don't really know the number, so this should be 5 with power of something. What number, when you have 5, what power should have if you need to become 1? It's 0, right? Do you agree with me? Agree? So 5, 0. So the whole log x is equal 0. So when log x is 0, x is, you know, when log x is 0, x is 1, right? So x is 1. That's the first answer. The second is when a is 5. So 5 with the power of log x is 5. Of course, this 5 is only having one power here, right? So log x equal 1. So x is 10. Okay. Okay. Any questions? No. Okay. So how do you feel about the quiz yesterday? Feel disgusting? Okay. Okay. So actually, we are if we are discussing about the quiz, the final, and etc., it will be related to how can I grade your score. Okay. So to make some notes here, um, actually I never really failing students from our course, this basic math, because this is basic math. So whatever scores you get, when I convince that you are understand the concept, I will still giving you a try. Okay, you can pass. But okay, there is a but. Okay? But if I see you don't really have enough uh, understanding and concept, I think I failed one or two students before. I think two students failed because first is um, because he doesn't understand what I'm saying, and second he is lack of um, math concept. So he doesn't really understand it. Okay. Okay. I will put the solutions in the Moodle system later. You can review if you want. Okay. So that's chapter 1. Actually, in your book, this should be 2, 3, 4, because chapter 1 is like a number, how to count a number, what numbers made of, real numbers, okay, from the natural numbers until the at least the complex, the real. Okay. Okay. So this is 2, 3, 4. Okay. And the next 3 chapters is actually about trigonometry. Trigonometry. But I will make some adjustment. So I don't think we really need whole 3 chapters because I think at least you know what trigonometry is. Okay. 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 Okay, so let's move on to trigonometry. Oh, why? What's happening? Okay. Okay, let me just. Uh, okay. Okay. So trigonometry. If you slice the trigonometry in the word, okay, you have tri is 3. Okay, the gon is from polygon. Okay, hexagon, trigon. Okay, so it's the sides. How many sides you have? Pentagon, right? And metry related to a metric or measurement. Okay. Okay. So trigonometry is basically a knowledge for three sides. So you have any shape that has three sides. Okay. Obviously, it's triangle, right? It's obviously a triangle, and you need to have a measurement. So inside a triangle, to measure the relations, okay, between all the sides in triangle. Let's say this is your triangle here. You need to have the sides and the angle. But I think you already know the nature of it. So you have the ratio. Okay, if you have this ABC as your triangle, so you will have the ratio. If you have A, B, C, you have A over C, you have B over C, you have A over B, as in your sine, cosine, and tangent. Okay, I'm not sure if I've talked before. I think in calculus, not in this class. So do you know why the name is sine, cosine, tangent? Have you asked your teacher before? Why this is the name is sine? Why you call it sine? So historically, okay, this is just a short history. So the how you deal with the angle and the in the triangle is it's from India, the first civilization to measure the angle in three sides angle. It's in India. So here's what they are doing. So you know a bow for archery. This is the bow, and this is the string. When you uh, pull out the strings at really uh, maximum point, it's probably like this. Uh, okay. So they are trying to figure how uh, this sides relate to this sides relate to this side, and they came up with the name. Uh, I forgot the how to pronounce that, but and how to write in Sanskrit. But it should be right something like it's called ja and called the ja, which means the curve in a bow, which means the curve. So it means curving. So notice that when you have this bow, you can actually making a sense of what angle this is, right? Okay, get the idea from the bow. You can intuitively get an angle from your the bow. Okay, and then this was later translated to, I think this is Indian, and this translated to first is Arabic. I think it still have similar sounds with this. I forget it's Jib or Jeb um, or Juyub. I forget, but they call it still same um, for curve. But then it's translated to Latin. I think this is I think there is some mistranslation when going to Latin, but still similar meaning. Similar meaning. It becomes uh, still same curve, uh, like a boson, like that. The curve, okay, and it's become the sinus, or maybe in I think it's in Spanish it's sand, right? Sand, right? But it's the same meaning. Like in your nose you have sinus, right? Why it's called sinus? Because it has curve, so we call them sinus. The same sinus as in sine here. Okay. Okay. It seems not really that matter, but if you are dealing with terms, uh, it's a really good idea if you are going for basic definitions. So what we are really doing here. So we need to find the relations, okay? Relations, sine and cosine and tangent. So we got sine, okay, as in curve. Okay? And what is cosine? Cosine simply means it's a complementary of sine. It's a complement of sine. That is cosine. Okay? And tangent, okay, you can also relate tangent with your calculus. Tangent line, right? The gradient. Anything that is tangible to a curve at one point is tangent. It's also, I think, Latin word, but we can also think it's as a tangible at one point as tangent line, which is our y over x, right? Or our a over b, okay? And we got all of this as ratio, okay? I believe you should have the ability to tell which one is sine, cosine, and tangent from the triangle, okay? I trust you. Okay, we can connect here. Let me check this. Just wait a moment. Okay, hopefully it's working. Okay. Okay, now I want to look at the circle. Okay. So the first sections will be about the unit circle. Okay. The first section of trigonometry is the unit circle. So how we are making sense for the circle and relate the circle to our trigonometry. So first, okay, let me make this a little bit bigger. So first, let's make this unit circle has a specific radius 1. That's the definitions. Okay, I want to make the definitions. This is 1 radius. This is 1 radius. Okay. Okay. And then let's put some line, okay, in between these positions when where x is positive, y is positive. Let's put some line here. Okay, we have line, and this line is also radius. Okay, this is also 1. And let's make our triangle from before putting here. Okay. Okay. And let's define some angle here. And let's say the angle theta. Okay. Okay, let's say we have some x here, some y here. So if I have this is y, this is x, okay. I can rewrite my sine and cos, right? So let's write sine theta. What is sine theta from this triangle? What is sine theta? Y over 1, right? So we can say this is y, okay? Or if you want to write completely, okay. And cos theta will be the other one, right? So x 1, okay. Okay. So in unit circle, even though you are hiding your triangle, at every point in x and y, it will be, so your xy will be cos theta and sine theta. Okay, got the idea? So your x is cos theta, your y is sine theta. So when you are having this point here, 1 and 0, so 1 and 0, it starts from here. The angle is between this and the same line, so it's 0 degree. So when cos is 0, it's 1, right? And sine 0 is 0. Okay, it's true, right? And then we can move this up until here. And we have 0, 1. And this is 90 degree. So cos 90 is 0 and sine 90 is 1. Got it? But when you are doing it the circle, basically you can imagine the ratios that are not showing in the triangle. For example, how you can imagine the ratio of sine 90 from the triangle. It's much more easier if you having this graph and have the relation of cos theta and sine theta. Okay. And to deal with this, okay, let's just see our signs. Okay. It's positive, right? This is positive, positive, all positive here, right? So the cos theta is positive, sine theta is still positive here. How about when we move a little bit here? Let's say maybe 95. Okay. Let's say it's sine 95. I don't really care about what is sine 95 as a number, but in sines, this is x, right? It's positive, x is negative, and y is still positive, right? Sine is our y. Okay. Y is still the same positive, right? So it still be positive, right? If you have cos 95, the cos is our x, okay? Our x. This x is negative, right? So we can write this is negative. And how about our tangent? Okay, sine over cos, positive over negative, it's negative, right? Because I remember back when I still senior high, these signs I I'm being forced to memorize the quadrant 1, 2, 3, 4, and what is the sign. But actually, I can explain better without memorizing it at all if I can derive this from the beginning, right? So if you forget like 180 minus pi sine, is it negative, positive? Sometimes you forget, right? So you can just make a circle, and you need to rotate the angle as much as you want. Okay, so okay, notice that I always start from here. Okay? So this is a definition. Okay? So the rotations of the angle we define from this x positive to towards this y positive. So it will be from here, here, and if you need more angle, you can rotate and you can reach. When you reach full circle, it's 2 pi, right? Okay. So always start with the x positive. This is your how to say that, your basic concept for rotating the angle, okay, in the unit circle. Okay. So when you have the 90, maybe it's here at the around here. So in here, let's say this is the first quadrant. We say this is the second quadrant. So in the second quadrant, only sign is positive. Okay, and then we are moving here. So it's passing the 180, maybe 190, maybe here. Maybe this is 190. Let me write sine 190. So sine in these positions is, this is positive of y, this is negative of y. Okay, remember our sign is y. So sine will be negative. And cos, this is positive, this is negative, right? So cos also negative. But because negative and negative, our tangent becomes positive. Okay, and that is the nature in the quadrant, then the third quadrant, and the last quadrant is quadrant 4. Let's say you have, this is 90, 180, 270, right? Or 3 over 2 pi if you like, and maybe around here, maybe let's say 300. Let's say here, maybe 300 here. Let's say sine 300, cos 300, and tangent 300. So in this point, x is positive, right? Meaning the cos value will be positive. The sine value will be negative, and the tangent, of course, it will be negative. Okay. Okay. So if you can derive the circle and make the definition of theta is from here, from this x positive, you can make sure that all the trigonometry that you have learned is correct, okay, by this unit circle. Okay. We can define this as cos theta sine theta. And even if you are having some problems in physics, like in kinematics, usually you have like usually the average cases is you are pushing the box, right? And it has an angle, right? And you can have the force in y and x, right? And you can also think, okay, what is x, what is y? It's just cos and sine. But depends on the radius. It depends on the what force it is, right? If it is force, then you can just write the radius at the front, because this is the radius because it's only one. I can just skip it, the one, right? But if you have some force in physics, you can just write f sine, f cos. Okay, okay, that's the introduction of the unit circle. Okay. And how you write the angle, usually, we can write, like for example, this 190. 190 is around here, but because our reference, okay, our reference is actually this angle, we can say that the whole pi here, we just need to add this angle, which is if this is same line, which is if this is the same line, this angle will be the same, right? So we can write this 3 quadrant pi plus theta, okay? And this one, you can write this also from pi. We can write pi minus this theta, okay? We can write that as pi minus theta. Or sometimes you want to have from pi over 2 plus something, also you can write, but I will make the same pi, okay? This is some angle writing that you can do. Okay? You can write in pi or maybe pi over 2 if this is, you want to look at this pi over 2 plus this angle. Okay? You can also do that. And for this part, the whole part is 2 pi. Okay? So if you want to make from this reference going up here, then you can say, you can use 2 pi minus this angle here. You can write 2 pi. But because 2 pi is actually first circle, you can just say it's minus theta. Or if you want to make sense, the whole circle here, when you are going here, it's positive, the degree is positive. When you're going here, the angle is negative. Get it? You can use that perspective. So you can, okay, plus 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 plus, the angle is plus, right? You can also see when it's going reverse, it's minus, the minus theta. Okay? But just make the positive as your default. Okay? Make that as your default. Okay, for understanding the whole concept. Okay. How many times? Okay, I think I will just stop here. Okay, for this unit circle. So every point here, if you have a special angle like 30, 60, 45, let's say 30. Okay, 30 is when you have sine is half, when you have cosine is half, and then square root of 3. So you can maybe here, this is the square, half square root of 3 and half. And you have 60 maybe here, or maybe 45 first, and then 60, and then 90. Okay, and it will be perfectly fit in the unit circle. Okay, so if you have some point in a special number with the angle, you can predict which angle is it. Okay, I think this should be easy, right? This should be easy. Okay, okay, I think I will stop here and see you next week. I will continue in the trigonometry.